Welcome to this explainer. Look, if you've ever felt completely paralyzed trying to figure out exactly which data tool you're supposed to learn to actually get ahead in your career, you are in the exact right place. Today, we're going to absolutely eliminate that overwhelm. We're looking at how Excel, SQL, and Python actually fit together in the real world. We're not going to read through dry technical manuals or recite boring textbook definitions. Nope. Instead, we're going to walk through a really practical step-by-step journey to understand exactly what each of these tools does, when you should actually use them, and crucially, which one you need to tackle first.
Here's the game plan for today. We're going to start with the data analyst dilemma. Then look at Excel, the familiar calculator. Move on to SQL, the Google for your data. Tackle Python, the automation machine. And finally, wrap it all up with your step-by-step career guide.
All right, let's jump right into section 1, the data analyst dilemma, and why learning in the wrong order actively hurts your progress. Starting out in the data industry, it can feel incredibly confusing. You go online and it seems like everyone is shouting at you to learn Excel, SQL, and Python all at exactly the same time. You know, someone says SQL is the only thing that matters, and then someone else chimes in about Python, and just scrambles your brain. The real problem isn't that these tools are inherently too hard. The issue is that nobody bothers to explain how they actually connect.
So let's ground this in reality, okay? Picture this. It is your very first day on the job as a junior data analyst. You just sat down and your manager drops a request right on your desk. Hey, we have some sales data. Just find out how much revenue we made last month. Sounds pretty simple, right? But here is the fascinating twist. You could solve this exact same problem using Excel or SQL or Python. Same problem, 3 completely different tools. But the one you choose completely changes your entire day. That brings us to section 2. Excel, the familiar calculator. It's fast, visual, and you don't need to be a programmer. If we tackle this day 1 task with Excel, well, everything just feels warm and familiar. You open the file, you physically see the rows and columns right there in front of you. You click a filter, maybe you toss in a quick sum function or a VLOOKUP, and boom, in like 3 minutes, you've got your answer. Task done, high fives all around. And honestly, this perfectly illustrates why Excel is literally everywhere in the business world. It is essentially a calculator on steroids. It's incredibly fast, it's highly visual, and the best part? It doesn't require you to know a single line of code. You get to literally watch the data change right before your eyes, which makes it the ultimate sandbox for beginners to learn how data behaves without getting bogged down by syntax. But you knew there was a but coming, right? There is a massive catch. Excel is an absolute dream when you're dealing with, say, 1,000 rows. But what happens when that data set suddenly balloons to 10 million rows? Yeah, suddenly you are staring at the dreaded spinning wheel of death. The application freezes, your formulas completely break, and your quick analysis turns into a hair-pulling nightmare. This is the first big realization you need to make. Excel is amazing until it suddenly isn't. Which leads us perfectly into section 3, SQL, Google for your data. Fetching information from databases. Because right when you hit that spreadsheet breaking point, our little workplace scenario naturally evolves to the next level. Remember that simple request from your manager? Well, they come back to your desk and drop this little plot twist. Oh, by the way, the data isn't in an Excel file. It's stored on the company database. Boom. The game completely changes. Why? Because you can't just double-click a massive corporate server like it's a spreadsheet on your desktop. You have to actively ask it for what you want. And this is where SQL swoops in. Think of SQL as basically Google for your company's data. Instead of scrolling through an infinite abyss of rows until your laptop physically catches fire, you just write a very simple query. You're basically typing out, hey, go get me the total revenue for last month. And SQL dives into this massive ocean of data, grabs exactly what you asked for, and drops it right on your desk. The beauty of SQL is that it literally doesn't care if your data is small or massive. You get your answer in seconds, no lag, no messy formulas breaking, no manual scrolling. But, and this is absolutely critical for beginners to understand, SQL does not analyze the data. It's a retriever. It is insanely powerful at fetching exactly what you need, but you aren't going to use it to uncover highly complex hidden patterns. And that pushes us right into section 4, Python, the automation machine. Building systems and predicting the future. We're about to push the boundaries of what we can do even further. Because your manager is back, and this time the ask is huge. Great job on last month's numbers. Now predict next month's sales. And by the way, automate this entire process so I don't have to ask you again. Okay, we are in a completely different league now. Excel, it's going to choke on that level of automated prediction. SQL, it's a retriever. It wasn't designed for forecasting. Enter Python. Python is essentially a machine that builds other systems. It is the bridge that takes you from being an analyst who just reports on what happened yesterday to an absolute powerhouse who builds robust, automated systems that run completely on their own and tell you what's going to happen tomorrow.
Let's look at Python's actual superpowers here. It can seamlessly clean massive, messy data sets. It can analyze incredibly complex patterns, build totally custom advanced visualizations, and yeah, it's the tool you use to create actual machine learning models. But the real magic? You can automate the whole shebang. Hours of tedious manual clicking can literally be reduced to seconds. But let's be real for a second. Python gives you a completely blank screen and a blinking cursor. There are no friendly buttons to click. It's intimidating, and you have to know exactly how to speak its language.
Okay, so moving to section 5, your step-by-step career guide, stacking tools for real-world success. Now that we've seen how each tool solves a very specific business problem, let's talk about how to actually get hired. What are hiring managers actively looking for? The single biggest mistake beginners make, and I mean this is a massive red flag in job interviews, is talking about these tools like they're competitors fighting to the death for the same job. Hiring managers don't want to hear you debate which tool is better. They want candidates who understand that Excel, SQL, and Python are layers. The analysts who stand out, the ones who get the offers, they know exactly how to stack these layers together. So, if you're starting from absolute zero, here is your concrete, no-nonsense roadmap. Step 1, Excel. Start here to learn the visual basics of data without getting overwhelmed by code. Step 2, SQL. Learn this so you can actually fetch the real-world massive data that companies run on. Step 3, Python. Bring it all together to build automated systems and predictions. In a real-world scenario, a top-tier junior analyst uses all three together. They'll use SQL to fetch 10 million rows off the server in seconds, pass that to Python to run a predictive algorithm, and then export the clean, summarized results right back into an Excel dashboard so their manager can actually read it. See how that works? Ultimately, making it in the data industry requires a total paradigm shift. We have to stop asking the completely wrong question of which tool is better. We need to replace it with the only question that matters. What business problem am I trying to solve right now? Once you identify the problem, whether that's a quick visual check, fetching a mountain of records, or automating a whole system, the tool you need becomes completely obvious. So as you start building your own data stack, I'm going to leave you with this thought. Stop trying to learn these tools in a vacuum. Look at the data problem right in front of you. What are you actually going to solve today? Figure that out, pick your layer, and the rest is going to fall perfectly into place. Thanks so much for joining me on this explainer, and hey, keep learning.